first is symmetric dataset, which is really important. Symmetric dataset. You will see a couple of questions. You can expect questions from symmetric datasets. Symmetric datasets are those datasets which are, well, symmetric. Okay, see, if you have this sort of dot plot, let's say you have the values as 1, 2, 3, 4, 5, 6 and 7. Okay, and the points are distributed like this. So you have okay, and here you have 3 points. You will see that this plot will be exactly symmetric. This is called a symmetric data set, Anika. Okay, here you can see that the points are symmetrically distributed around 4. Okay, and in this type of data set, the special thing is that the mean and median are equal. Okay, so your mean and median will be the same, and they will be the central number. Like here, this data set is symmetric around 4, so your mean and median, both of them will be 4. Okay, that's the only thing that you should know, and you'll be able to do a lot of questions based on this concept. Now a symmetric data set can also look like this. So if you have 1, 2, 3, 4, 5, 6, 7, so it can also look like this. Do you see what I'm doing here?
Yeah, so it doesn't always have to have like the most points in
Yeah,
the
in the center.
middle. It can have like the least number of points in the center and the most in the outer
Yes, and
part.
still this is also symmetric around 4, right? And so again, for this one as well, the mean and median will be equal, and they will be the central number, which is again 4. Okay, so Anika, this is your symmetric data set. The next thing that we'll do is the box plot. Have you seen a box plot, Anika?
Yes.
It is also called a box and a whisker plot. Okay, so it kind of look like this. So you have a box, there will be a box, and so this is called the box, and then there are whiskers. This line and this line, these are the whiskers. It is also called a box and a whisker plot. And these lines don't have to be equal, okay? They can be unequal as well. And then there will be a line like this. Now, Anika, this box plot is used to um, actually represent your data visually. Okay, because when we have our data visually, we can find out some insights faster than my voice is echoing. Okay, I was saying that
I was saying that.
now it's echoing even louder. Now it's better.
Okay.
Okay, so Anika, this box plot allows us to find out the median, the median, the first quartile. Do you know what are quartiles? Second quartile,
Uh, yeah. Well,
third, and fourth.
Think.
Okay.
Like, I guess, like, how the data set is, like, divided, if that makes sense, or, like,
Hmm.
sorted or organized. The
Hmm.
quartiles.
Yeah. So see, first of all, and with this plot, you can also find out what is the minimum value and the maximum value. Okay, now when you have this sort of box plot, first of all, the most important information that you can tell from this is the median. The median will be always given by this line which is inside the box. Okay, so this line tells us the median. Okay, and this, so you have a box and you have a whisker. So the whiskers, the tails of the whisker give us the minimum and the maximum value. So whatever will be this value, this will be the minimum value, and this point will be the maximum value. Okay, and then you have first quartile and the third quartile. So this point, this is your first quartile. Now first quartile is that point which divides your data in 25% on the left and 75% on the right. For example, if you have a, let's say you have these points, Anika, one, we change the color. You have certain points 2, 11, um, and the data should be arranged in increasing order. Okay, so 2, 2, 3, 3, 3, 5, 6, 6, 1, 2, 3, 4, 5, 6, 7, 8, and let's say 9, 10. Let's say you have this data, Anika. Okay, so the point, which point is the one which, first of all, which point divides the data into 50% and 50%? That's your median. Median is the middlemost value, right? The central value. So median divides your entire data into 50% points will be on the left side, 50% points will be on the right side. Okay, so can you tell me what will be the median of this data, Anika? We have 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median would be average of these two numbers.
So 4.
So 4. So there is well, 4 is not any point in this data, but you'll see that 50% of the points will be on the left side of 4 and 50% of the points will be on the right side of the 4. Now similarly, so you have your data in two equal halves, right? So you have, now if you divide this data in two equal halves, this and this, well, you can take this as well. Now if you find out the median of the left data, so you have two data sets now, Anika. You have this data set all the way till here, 50%, 50%. Now if you find out the median of this data set, that will be your first quartile and that will be represented by this point. So can you tell me what will be the median of this data set, the left one?
The left one, it will be 3.
3, exactly. So this value will be 3. Okay, and this is called your first quartile. This point divides the data set into 25% and 75%. So on the left side you have 25% of the values, and on the right side you will have 75% of the values. Then if you find out the median of this data set, the second half, it will be 6. So this number is 6, and this number divides the data set on 75% of the values will be on the left side and 25% will be on the right side. So that is your third quartile. This one is the third quartile, and median is the second quartile. Okay,
Okay.
so these three quartiles divide the entire data in four equal halves. Okay, base question. This one is on box plots. Okay, so here you have two box plots, Anika, and as you can see, the line. Wait, you can see that this line. This is not in the center. It's not necessary that it will be in the center. Okay, this just represents that most of your points are in the right hand side. If this median is in the right side, this means that most of your values are on the right hand side. That is why the median is on the right hand side. Anyway, so you have two box plots, Anika. Can you read all the options one by one?
Um, the mean mass of group 1 is greater than the mean mass of group 2. The mean mass of group 1 is less than the mean mass of group 2. The median mass of group 1 is greater than the median mass of group 2. The median mass of group 1 is less than the median mass of group 2.
Okay. So first thing is, remember that the box plots do not tell us anything about the mean. Okay, you cannot
Right. So
you
then I can immediately eliminate those.
exactly, you cannot tell anything about the mean by looking at the box plots. Okay, so option A and option B we can immediately eliminate, and then in option C and D they are comparing the median of group 1 and group 2. So can you find out the medians of both the groups?
The median of group 1 is 25 and the median of group 2 is 24.
Exactly. So now we can compare both the medians, and C would be correct. Median mass of group 1 is greater than median mass of group 2, right?
Right.
Since 25 is greater than 24. Okay. So this completes, Anika, your one variable data sets. Now we'll start with two variable data sets and hopefully probability as well. Okay. In two variable data sets, Anika, you have to just do the scatter plots. And scatter plots, the questions of scatter plots are really easy. Most of them will be about interpreting the slope and y-intercept of the line of best fit. So you have a scatter plot. Let's say it looks like this. Okay, you will be given a
Okay.
scatter plot like this. Now you can have three types of scatter plots. One is this. In this one you can see that, so on the x-axis you have some quantity, let's say it is x, and on y-axis you have another quantity, let's say it's y, and you can see that there is a positive correlation. This represents correlation. That means as we are increasing the x values, the y values are also increasing. That is called the positive correlation. And if we try to draw the line of best fit, it would be kind of like this. Okay, it is used to make predictions. Now if I want to find out that I have if the x value is here, then what will be the y value. So we can just go to the line of best fit, although we don't have the actual point for this number. See, I don't have any point over here. It could be here, it could be here, it could be here. We don't have the actual point, but we can make a prediction. So if x is, let's say this point is 20, so you just have to take the y value of this line. What will be this line? What will this line tell us? Okay, but the actual point could be here, could be here. So that's why we will get a predicted value. Okay, Anika. So this is the positive correlation. Then similarly, you can also have negative correlation. That will look like this, where you'll have a negative slope. Okay, and the line of best fit would be falling line with a negative slope. It will kind of look like this. And then there is a case of no correlation. So you have this, you have this. Then no correlation will be where the points will be just random. Okay, there will be no correlation. Okay, so this is positive
Okay.
correlation, this is negative correlation. Now the questions from this, Anika, you can expect. I think in this document you have both the questions of one variable and two variable. Okay, let's see. Mm. See, Anika, yeah, okay, that question is in this document, not in this is the one that I was trying to find out. This is based on symmetric data set. So it says that you have two data sets, data set A and data set B. Which of the following statements must be true? It says median of data set A is equal to the median of data set B, and standard deviation of data set A is equal to the standard deviation of data set B. Okay, first let's see about the median. Anika, would you say that this is a symmetric data set?
Yes.
It's symmetric. And what about this one?
Also symmetric.
Also symmetric. So we can find out the median for both of them.
Yes. It's equal.
Equal. But it's not necessary that median or medians of two data sets will be also equal. In this case, they are equal. Well, you have to find it for both of them. So for the first one, it is 13, and for the second one as well, it is 13. That's just a coincidence. Okay. So yes, the first statement is correct. The median of data set A is equal to median of data set B because they are symmetric. So this was 13, this was 13. What about the second one, Anika? Standard deviation of dataset A is equal to the standard deviation of dataset B.
Mm, I think it's equal.
It's equal? No, Anika, it's not going to be equal. What was standard deviation, you remember?
Like either how close or far apart data is.
From the mean. How close the points are
Oh, from the mean.
from the
Okay.
mean. So I think in dataset A, the points are closer to the mean. The mean will be also 13. Would you say that the points are closer to the mean in dataset A or in B?
Yes. I think in A.
In A, they are more closer to the mean in this one, and in this one they are far from the mean. Here as well, the mean is 13. So which of them will have less standard deviation? Which of them will have more? Can you tell?
Um, so A will have greater standard deviation.
No, Anika. When the points are
Oh, it's the
close,
reverse. It's the reverse. So B will have more standard
yeah. So
deviation.
see, you have to. How will you remember this? You look at the word deviation. It's all in the name. Just focus on the word deviation. Deviation means what? That how much the points are deviated from the mean. So from deviation, remember deviated.
Okay.
So if the points are more deviated from the mean, then the standard deviation will be more. Okay? And if the points are less deviated means they are closer to the mean, then they're less deviated, so the standard deviation will be less. Okay, so the standard
Okay.
deviation will be more for this because here the points are more deviated. Okay, but anyway, the correct option will be option A. We just have to find out whether it will standard deviation will be equal. No, it will not be equal. So statement 2 is not correct. Only statement 1 is correct. Okay, this question was I wanted to discuss. Now I want to do one question from two variable data set. Yeah, questions like these. So this is a scatter plot, Anika, and you can see there is a line of best fit. Wait, clicked. Okay, let's. There is this one as well. I think this is easy. I want to do that one. See, Anika, here in most of the questions you will be asked to interpret the meaning of slope and the y-intercept given in the assignment. But if you see, yeah, this one is about interpretation of slope and the y-intercept. If you see, Anika, this is another type of question that you can expect. Each dot in the scatter plot above represents the temperature and the number of people who visited a beach. So on the x values represent the temperature and the y values represent number of people. So Anika, whenever you have a dot plot or a scatter plot like this, you should be able to think in your head that okay, as per this graph, as the temperature is increasing, the number of people on the beach is also increasing. This is how you should be able to interpret the graphs, okay? As the temperature is increasing, the number of people who are coming to the beach, it is also increasing, right? That's the interpretation of this graph since it's an increasing graph. Okay, now let's see what we have next. The line of best fit for the data is also shown. The line of best fit has a slope approximately 57. Okay, so the slope is 57. According to this estimate, how many additional people per day are predicted to visit the beach for each 5-degree increase in average temperature? So, Anika, this one is based on the concept that I told you. Interpretation of slope, it's given by slope is actually the change in the y values for every, you remember this?
Yes, change in y values
Hmm.
for every x value, or
For every 1 unit change, this is important, 1 unit
one
change
unit change.
in the x values.
I just usually memorize slope as change in y over change in x, so
That is
I don't
correct.
confuse myself.
That is correct. It is change in y over change in x. That is the graphical interpretation. Okay, but the real world interpretation, when we talk about real world context, the slope always tells us the change in the y values for every 1 unit change in the x values. So if we think about this, they have given us that the slope is approximately 57. So what does the slope tell us, Anika? What is 57 actually? Change in the y values. That means change. What are y values here? Number of people.
No, number of people in the x values are is the temperature, the average temperature in centigrade.
Yes, so that means 57 is change in the number of people for every 1 unit change in the temperature. That means what? Whenever the temperature will increase by 1 degree Celsius, you will see 57 more people on the beach. Does that make sense? For example, if let's say right now the temperature is 29 degrees Celsius and there are, let's say, 240 people, and if the temperature increases by just 1 degree, if from 29 degree it becomes 30 degrees, you will see there will be 57 more people. So add 57 to this, so you'll get 297 people. This is the interpretation of slope. So if the temperature will increase by just 1 degree, there will be, the people will increase by 57. There will be 57 more people on the beach. Okay? So now it's asking
Okay.
that if the temperature increases by 5 degrees, then how many additional people per day are predicted to visit the beach? So basically, they are just asking that if there will be a change of 5 units, then what will be the change in the number of people?
Oh.
So, what will be the answer, Anika?
Um.
See, when there is a 1 unit change, then you are getting 57
It
additional
change
people.
it, right?
What?
So I was gonna say for each 1 unit change, that's like 57
Hmm.
more.
Yeah, so you have to do it for 5 degrees.
So 5 times 57.
Yes, 5 times 57. And that will be your answer. 5 times 57, whatever that will be the answer. Okay.